In section 2.2 of your text, we will begin to talk about the inverse of a matrix. Before we learn about how to find the inverse of a matrix, let's just kind of start at the beginning and understand what is an inverse and refresh our memories about identities. So let's start by something very easy, which is an algebraic example. And the first expression or equation I have written down is 3 times 1 equals 3, which we all know. The reason I write it down is that 1 is called the multiplicative identity. So what we know about the multiplicative identity is that I can take any value times 1 and end up back at that value, or x times 1 is equal to x. So it doesn't matter what value x takes on, if I multiply anything by 1, I end up back at that value. The reason I bring that up, and again this is the identity, is that I should now be able to find something called an inverse. And an inverse is a value that you would multiply by your original value to get back to the identity. So symbolically, I would say that x multiplied by the inverse, and this is how we denote that, x to the negative 1, that tells us that that's the inverse, is equal to the identity. So now let's take a look at matrices instead of an algebraic problem. In matrices, I have matrix A, and matrix A multiplied by the inverse matrix should get me back to A. And notice, with the inverse, I can actually multiply those two in either order and end up back at A. So just as a refresher, in case you have forgotten, the inverse matrix is a square matrix. It's a square diagonal matrix with 1 in the diagonal. So 1, 0, 0, 0, 1, 0, 0, 0, 1 would be the identity matrix for 3, because there's 3 rows, 3 columns. So looking at kind of similarly to the way that we looked at it in algebraic terms, if I took A multiplied by the inverse of A, and notice that same notation, or if I took the inverse of A times A, either way I should end up back at the identity matrix. A bunch of 1s in a diagonal with the rest zeros. So that's what an inverse is, and obviously what an identity is. Notice at the very bottom I have sort of a definition here, and it's only part of a definition, and we'll finish the rest on the next page. But I wanted to talk about, how do I know a matrix is invertible? Well, this is obviously specific to a 2 by 2 matrix. To know if a 2 by 2 matrix is invertible, I would take A times D, which is that first diagonal, minus B times C, which is the second diagonal, and if that is not equal to 0, then A is invertible. This value is called the determinant of A, and that's how we denote that. So the determinant of A is AD minus BC. So we'll talk a little bit more about that on the next slide, but again, this is how do you know it's invertible? You would find the determinant, make sure the determinant is non-zero. Looking specifically at a 2 by 2 matrix, I've now given you the rest of this definition or theorem. And the theorem says that the inverse of a 2 by 2 matrix can be found first by verifying that AD minus BC is not equal to 0. And again, that is the part that we talked about already. We need that determinant to not be equal to 0. Therefore, A is invertible. And then it tells us that A inverse can be found using this formula. So notice this formula is really 1 over the determinant of A, because we talked about that being the determinant. And then notice what happened to the values. A and D just switched places. So it started as A here and D here. To find the determinant, I'm going to switch the first diagonal. And notice the second diagonal, B and C are in the correct spot, but they're negatives. So the first diagonal, I'm going to change the values with each other, and the second diagonal, I'm going to change the signs. Now, before we actually use this formula to find the inverse of a 2 by 2 matrix, let's just talk about the fact that it is going to work. So I know, based on what we talked about before, that A times A inverse should give me the identity. So let's do that symbolically. A, B, C, D times 1 over AD minus BC multiplied by D minus B minus CA. So that's A times A inverse. And supposedly, if I do all of this work, I should end up at the identity. And remember that the identity, in this case, would be 1001. So let's just test our mathematical ability and see if that's what we get. If I take, and I'm going to just make the computations easier by popping this to the other side. So we know that's a scalar, and a scalar can be put on one side or the other, and it's not going to change it. We talked about that in our last video. So I'm going to focus first on just multiplying the two matrices together, and then at the end I'll multiply by that scalar. So I'm going to put the scalar out front. And I'm going to multiply the matrices. So I'm going to take my first row, AB times my first column. So that's A times D plus B times negative C. So I'm just going to change that to minus BC. And then first row times second column would be negative AB plus BA. Let me go ahead and switch back to yellow for that other bracket. And then I'm going to take my second row and do the same thing. So C times D plus D times negative C, so again minus CD. And then C times negative B plus D times A. So let's do a little bit of cleanup here. So I still have this scalar, which AD minus BC, and I could put that at the beginning or the end because it's a scalar and it doesn't matter. But let's do a little bit of cleanup. AD minus BC is just AD minus BC. That my second term minus AB plus BA, well, these are the same thing, AB and AB. So I have minus AB and positive AB, which gives me 0. And then CD and CD, that's 0. And then I'm just going to change the order here. I'm going to put AD first. So AD minus BC. And we can see now, if I take each term multiplied by my scalar, that I'm going to end up with AD minus BC over AD minus BC. And that's just 0, and that's just 0, and that's AD minus BC over AD minus BC. And that gives me 1001. And therefore we have shown, this is not a proof, but we have shown that will in fact give us the identity. No! Here's a practice for us to do together. It says find the inverse of A and verify it is the inverse. So again, I probably should have rewritten that formula for you since I doubt that you have it memorized by now. So we have AD minus BC, and remember D and A switched places and B and C switched signs. So that means, again, my original matrix A is A, B, C, D. So I'm just going to use this formula. I'm going to take 1 minus, and then AD would be 2 times 4. I'll just go ahead and write 2 times 4 so we remember where everything came from. 2 times 4 minus 0 times 1. And then remember how I find this. I'm going to take these two and switch places. So the 2 and the 4 will switch places, and the 1 and the 0 will switch signs. So -1, and obviously there's no such thing as -0, so it's just 0. Now I'm just going to do the computation. So 1 over, that's 8 minus 0, so 1/8 times, oops, I'm taking up a lot of room there, so let's try this again. 1/8, and then 4, -1, 0, 2. So if I take 1/8 of each of those, and I'm going to go ahead and take 1/8 and reduce, so 4 over 8, which reduces to 1/2, -1 over 8, 0 over 8, which is 0, and then 2 over 8, which is 1/4. So that is my inverse matrix for A. Now I'm going to verify it is the inverse. So to verify, I'm going to take A times A inverse, and that means I have 2104 times 1/2 -1/8 0 1/4. And again, you can feel free to help yourself with a calculator, but it's good for you to do mental math. So if you can do it without a calculator, that's what you should do. So here we go. I'm going to take 2 times 1/2, which is 1, and 1 times 1/4. Hold on. Nope, just kidding. 1 times 0, which is 0. I knew that was wrong. And then I'm going to take 2 times -1/8, which is -1/4. And I'm going to take 1 times 1/4, which is 1/4. And that was my first row times each column. And now I'm going to take my second row. So 0 plus 4 times 0, which is 0. And then 0 times 1/8 is 0. And 4 times 1/4 is 1. So what did I end up with? 1, 0, 0, 1, which is the identity matrix. Now, just for fun, because math is so much fun, let's take A inverse times A and verify that we do, in fact, still get the inverse. The identity. So the inverse, again, was 1/2 -1/8 0 1/4. And if I take that times A, that is 2104. And now let's do the math and hope that we end up back at 1001. So 1/2 times 2 is 1, -1/8 times 0 is 0. That's that first row times the first column. First row times the second column is 1/2 times 1, which is 1/2. And then -1/8 times 4, which is -4/8, or -1/2. And then obviously I'm taking it times 0, so I get 0 times 2, which is 0, 1/4 times 0, which is 0, and then 0 times 1, which is 0, 1/4 times 4, which is 1, and guess where we ended up? 1, 0, 0, 1. Here's one for you to try on your own, so go ahead and try this question. When you are ready, press play to see how you did. So again, if I were starting to find the inverse, and this is a step we kind of skipped on the last one, we know that the inverse is 1 over -16 minus -16. So right away, hopefully you noticed that it doesn't matter if I switch the order of these two and the sign of these two, because what's going to happen here is -16 plus 16 is 0, and because this is 0, that means the determinant of A was equal to 0, and therefore this is not invertible. So pay attention, because sometimes you will get questions like that where you're asked to find the inverse and you are not able to.